All right, so we're on 3A.6, applications and activities. So the problem that we're talking about is the doubling coin problem, okay? So the doubling coin problem starts off with, suppose that you have a coin whose value doubles every day. That is, on the day you get the coin, day 0, its value is $1. On day 1, its value is $2. On day 2, its value is $4, and so on. Doubling in value each additional day. How many days must you wait for the coin to be worth $1 million? Trying to figure out in the end, okay? So we're going to take this and we're going to break it down into parts. So the first thing we're going to start off with is talking about the doubling coin represents an example of what? Exponential. Good job. Okay. It's an example of exponential growth, okay, where a value is repeatedly multiplied by the same factor. Our initial value here is what? 1. So based on the pattern that we have, what would be day 1's value? Day 1, day 2, day 3, day 3, 8, day 4, okay? Because it's doubling in value every day, right? Not not adding, but we're multiplying by 2. Okay. Right? So again, so reiterating, the type of function that represents repeated multiplication is called an exponential function. Exponential function. An exponential function can be a growth or a decay. Okay. The general form form of our doubling function is based off of that. So f of x equals your a times b to the x, where x represents your days. X is always typically some form of time, right? Your initial value is your a. And for this problem, a equals 1. Your base is your change, right? How are you changing? Is your change, and therefore is changing by 2. And we know that because it said the value was doing what every day? Doubling. Doubling is, well, that's what the word was, but it should be doubles. I know English, don't worry. It doubles, but in the thing it said doubling, right? Isn't that what it said? The doubling point? Yeah. All right. So the graph will. So what would our equation look like if we were to graph this? Well, we're not going to plug everything in. So our A would be 1. Our B would be 2, and it's to the X. This graph is going to always stay what? Positive. It's going to always stay positive. And is it increasing slowly or quickly? Quickly. Because imagine we went from day 0 of 1 to now being at day, what we're at, 4, at 16. Okay. All right. The domain, keeping in mind, because days cannot be negative, where does your domain begin? 0. Okay. Your range, keeping in mind that your initial value was 1, where does your range begin? At 1. Yes. So the bracket means that it can be. Like I can equal 1 and I can equal 0, right? Okay. If it's parentheses, I cannot equal them. It's just my boundary line, but I can't equal them. Okay. Welcome. Thank you for asking. All right. So what, and ultimately you will be working on solving within your group and partner practice is we need to solve what? Yes. So what goes in this blank? There we go. 1 times 2 to the power of x is what you're going to have to solve. And then you're going to decide, would you rather prefer a single payment or a doubling point? Okay. So important vocabulary coming together, all together. Our base is always going to be greater than 0. I put the greater than symbol, will that be okay? Always greater than 0. Okay. Our exponent is always our independent variable. And it's typically going to represent our time. Your initial value is your amount at x equal 0. What is your value at x equal 0? And your growth factor, you know that it's a growth factor if your base, your b, is greater than 1. What makes it greater than 1 is that it's 100% plus your percent change. I know we don't have it on here, but just to make sure we understand decay factor, your decay factor, it would be between 0 and 1. Does that make sense? Okay. And that's because B being negative isn't a thing. So in order to represent the decay, it has to be a fraction. I'm losing an amount every time, right? A certain percentage every day or every minute, every whatever. Okay. So these are all the notes that you have. These notes are going to help you get through your partner and group practice. So tomorrow, you're going to start here with the group practice. So your group practice is analyzing the stuff we took in our notes, and you're going to write your function, justify the type of function, explain why that's the function. Did we just not go through the notes and have the tools to be able to explain? Yes, we can. And then you're going to create a graph based on that, okay? How would you use this function model to decide? Go from there, okay? Then on the next part 2, you're going to work as a group, come back together. So after you and your partner finish, you're going to group up with some other people, and you're going to decide, answer the following questions pertaining to the doubling point, okay? Yes? All right. I appreciate y'all. Y'all are awesome. And that's all I got for you today.